Okay, this video here is about preparing to derive. Okay, if you're going to derive, you need to get a few things worked out before you actually do the deriving. Okay, if you have y equals something, let's say 3x squared minus x on 2 plus 3 on x. Okay, if we have something like this, what we want to do is get it in a nice form first before we derive. So we once again go y equals 3x squared. We can derive that easily, so we're going to leave that like this is. This one would be nice to have it as a minus a half x. That's a nice form to derive in. Okay, and I don't want to have an x on the bottom. Okay, that's my first rule of deriving. Okay, so I want to have that as 3x to the negative 1, which is a much nicer form of deriving. Okay, once I've got it looking like this, I am ready to derive. Okay, so then I can go dy dx. So make sure you do that extra line if you need to. Okay, 6x. Okay, this become an x by itself just becomes a 1. So we just go negative a half. Okay, plus, well, that's actually going to be negative 3x to the negative 2. Okay, once I've got it derived like so, I can then rearrange again, but I want to make sure I get it into this form first. So this is a good form to derive into that form. That's not such a good form, but this is. Okay, so get it into a nice form. You also want to make sure you split your numbers up. So let's try this one. What if it's y equals 3x squared plus x minus 1 all over x. Okay, if we have something like that, this is not nice. Okay, we can't do this kind of regular deriving in that form. What we're going to do is we're going to split it up into 3x squared over x plus x over x minus 1 over x. And I'm still not happy with that. This is still y equals. Okay, y is going to equal 3x, because I'm cancelling out those two x's, plus 1, because I'm cancelling out those two x's, minus x to the negative 1. Okay, now I'm in a good place, and I can easily derive that, okay? So then I go to my next line. Make sure you write your dy dx, because no longer does y equal whatever you're going to write next. This is your derivative equals whatever you're going to write next. Okay, so 3 plus 0 plus x to the negative 2. That minus 1 comes down, changes that minus into a plus. We minus that 1, another 1 from that minus 1. Okay? And so dy dx is going to equal 3 plus x to the negative 2, or 3 plus 1 over x squared, which is the same thing. Okay? So that's your answer. So this derives into that. Okay, so that's a nice way to do it there. Okay, you also, it's easier if you expand out brackets. What if you had something like y equals x plus 3 x squared minus 1 on x. Oh gosh, that looks nasty to derive in that form, but if we expand it out, I'm sure it's going to be fine. Okay, so expand that out, and expand this out, and expand this out, and expand this out. Okay, so we're going to get x cubed minus x over x plus 3x squared minus 3 over x. Okay, this is still y, and I'm still not happy with this. Y equals x cubed, I can derive that, that's fine. Minus 1, I can derive 1, that's fine. Plus 3x squared, I can derive that, that's fine. Minus 3x to the negative 1. Okay, now I can derive all that. So then I go to my next line, so this is a good one here. This is prepared to derive. Okay, and we're going to go y equals dy dx equals 3x squared. Make sure you write that dy dx, because it's not y, it's dy dx equals this. 3x squared minus 0, so I won't even put that in. Okay, plus 6x minus, well, it becomes a plus because the minus comes down here, plus 3x to the negative 2. Okay, and that's my answer there of my deriving. Okay, so remember to prepare to derive. Okay, and that you can do by turn fractions to negative powers. And you can also split up your terms. And you can also expand brackets. If you can do any of these things, then that is your preparation to derive. And then, after you've prepared, then derive. Okay, that's the basic rules.